Overview. Last session we talked about statistical significance. We said that the p-value in social sciences equals 0.05. Next, we talked about suggestions for finding a topic, correlation and partial correlation, regression analysis, and chi-square. Today, we will talk about inferential statistics again, and we will focus on tests of group differences. If you remember, in the previous sessions, we said that we have two major types of statistics, namely descriptive statistics and inferential statistics. The selection of statistical tests depends on understanding the distinction between tests of relationships and tests of group differences. Generally, you will need a test of relationship if all of the variables are continuous. For example, is there a relationship between students' second language reading scores and their scores on the aptitude test? This is test of relationship. If you have a mixture of continuous and categorical variables, you will probably need a test of group differences. For example, does input enhancement through reading affect EFL learners' vocabulary knowledge? This requires a test of group difference. So, in the following slides, I will talk about different tests of group differences. Tests of group differences can be categorized as three major types: t-test, ANOVA, or analysis of variance, and ANCOVA, analysis of covariance. We have two types of t-tests, independent samples t-test and paired samples t-test. Also, we have different types of ANOVAs, one-way, two-way, n-way ANOVA, multivariate analysis of variance, or MANOVA, and we also have repeated measures ANOVA. Before moving on to the issue of tests of significance, there are a number of key terms that need to be defined clearly. Variance. Variance is the mean of all squared deviations from the mean. Total variation can be partitioned into two sources of variability: between groups variability and within groups variability. Between groups variability is variability among scores of participants who receive different experimental treatments, while variability within groups is variability among scores of participants who receive the same experimental treatment. For example, we have one group, and in that group we have 3 times of testings: pre-test, post-test, and delayed post-test. And we want to see the development of the students from time 1 to time 2 to time 3, pre-test, post-test, delayed post-test. This is a within group analysis. But sometimes we have 2 different groups, we have 2 different post-tests, and now we want to compare the results of the post-test in the first group with the results of the post-test in the second group. And this is a variability between groups. Next is degrees of freedom, or DF. The number of values free to vary given one or more mathematical restrictions. The fact is that DF here is sometimes referred to as DF error. You see this abbreviation DF in the output tables of SPSS. Next is p-value. How likely it is that you would have obtained similar results due to chance alone. The likelihood of committing a type 1 error. This is p-value. And sum of squares, or SS. It is the sum of squared deviations of some set of scores about their mean. Next is mean square, MS. Mean square is a variance estimate obtained by dividing a sum of squares by its degrees of freedom. F ratio. F ratio is the ratio of the between group mean square to the within group mean square. A significant F ratio tells you that the differences among your means are caused by the different treatment conditions, that is, different levels of your independent variable. Multiple comparisons. An ANOVA can reveal that the means are not all the same. But we are left with the question of which means are different. Post hoc tests are done after the ANOVA is done and shows that there are indeed differences amidst the mean. In fact, a post hoc test enables you to go back through the data and compare the individual treatments two at a time, and to do this in a way that provides the appropriate alpha level. There are a number of different kinds of post hoc tests in SPSS. For example, the one that we use mostly is 2-case HSD. It determines a single value that is the minimum difference between a pair of groups that is needed for the difference to be significant and a specific alpha level. I will explain this post hoc when I talk about ANOVA in the following slides. The first test of group difference that we want to discuss is t-test. In fact, there are 4 main assumptions for t-tests. First is that the dependent variable should be measured in interval scale. Second, the data should be independent. And third, the data should be normally distributed. And finally, groups should have equal variances. These are the main assumptions that should be met prior to running the t-test. If one of these assumptions can't be met, then you cannot use the t-test. T-test is used when we intend to compare two means of two sets of scores. Remember, if the means are from two sets of values that belong to two different groups, we use independent samples t-test. If the means come from the same group, we use matched t-test or paired samples t-test. Therefore, the t-test determines whether the difference between groups or two sets of scores are small enough to attribute them to the random variation in scores that would happen each time we take a new sample of the same population, or whether the differences are large enough that the two groups can be said to belong to two different populations. So we use a t-test when we have two sets of scores and we want to see the difference. In fact, we want to see if the difference is significant or not. Now, the first type is independent samples t-test. It is used when you perform an experiment and you have obtained mean scores from two independent groups. Remember that here we're talking about two different groups. For example, you want to investigate the effect of teaching a strategy of writing on the quality of the students' writings. Here you choose two groups. One is the experimental group in which you teach the strategies, and the other one is the control group. You have post-test for these two groups. So you have two sets of scores for the post-tests. And you have mean scores of all of the students in these two groups. The students in these two groups are different from each other. Here you can use independent samples t-test. Therefore, it assumes that the two mean scores are independent of each other. There are some attributes for independent samples t-test. First, it has exactly two variables, not more. One variable is categorical with only two levels, and it is the independent variable. People in each group must be different from each other, as I said, for example, an experimental group and a control group. The other variable is continuous, and it is the dependent variable. And considering the means, you have only two means, because you have only two sets of scores to compare. Therefore, you only have two means. In that case, you can use independent samples t-test. The non-parametric alternative of independent samples t-test is Mann-Whitney U-test. As I said before, you can use the non-parametric alternative of each of these statistical tests, like, for example, t-test, ANOVA, MANOVA, and COVA. You can use the non-parametric alternatives when, for example, you have a problem with the data, when the data is not normal, for example. You can use the non-parametric alternative. This figure illustrates the condition in which we can use independent samples t-test. If you pay attention, you can see that we have two different groups with different participants. For example, A, B, C, D, E. These are the students. All of the participants do all of the treatments or the conditions. For example, in one group, the treatment is teaching strategies for writing. The other group is, for example, the control group. But the fact is that here the dependent variable which is measured should be the same. At the end, we run a post-test for both groups, and that post-test should be one thing. For example, for both groups, it should be a writing test with the same topic. Later on, you can analyze the results using independent samples t-test. Look at this example. You have completed a research study looking at the effectiveness of two kinds of feedback on learners' vocabulary test scores. Group 1 has 35 learners and Group 2 has 33 learners. You have calculated the means and standard deviations of the end of semester exams of the two groups, and you believe that all of the assumptions for a parametric test have been met, for example, normality, equality of variance, and the rest. So the statistic that you need here in order to compare the two groups is independent samples t-test. One group 30 learners, the other group 33 learners, and you have the same test, vocabulary test. Now you have two sets of scores, one for group A, the other for group B or group 2. You use independent samples t-test in order to analyze the results. In the next slide, I will provide an example using a research question. Here is another example. Research question. Do English-speaking learners of Japanese who receive pronunciation training on a computer improve their performance on pitch and duration contrasts in Japanese more than control group? Here again we have two groups. One is the control group and the other one is the experimental group. In the research question, we mentioned that we have Japanese learners, and we can see that they receive pronunciation training using computer. So the independent variable is pronunciation training using computer. When we go on, we see that the dependent variable is their performance on pitch and duration. So this is the dependent variable. We have two different groups, experimental and control, and we have one dependent variable which is pitch and duration. So we have two sets of scores on pitch and duration, and we have independent samples. Therefore, we can use independent samples t-test. It examines whether the difference between a group that received an experimental treatment and a group that did not receive it is large enough to conclude that the groups are different from each other significantly. This is an example of the table of independent samples t-test from the output of SPSS. Assume that you wanted to compare the mean scores from two classes on a test of grammar. And this is the result. If you pay attention, you can see that this table has two major parts, the columns. One is Levin's test for equality of variances, under which we have two other columns, F and Sig. This test tells us whether the data sets display equal variances or not. Note that this was one of our conditions to be met for using a parametric test like t-test, and we said that before. If this test shows significant results, that is, the value mentioned here is below 0.05, then equality of variances cannot be assumed, and we should use the results reported in the bottom row of the table. In this example, Levin's test does not show significant results. The value is 0.891. this value is higher than 0.05. Therefore, it does not show significant results. Therefore, we use the results in the row that corresponds to the equal variances assumed. If this value is below 0.05, then we should use all of the values in the row at the bottom, equal variances not assumed. Next part is T. T is the observed measure that tells us about whether the sample mean is similar to the population mean. Next is DF. I talked about degree of freedom before. And next column is sig two-tailed. This is the most important value in this table. The only thing you have to do is to pay attention to this column, sig. Here is the interpretation of sig. This statistic must be checked against our level of significance, alpha level. As I said before, level of significance in social sciences equals 0.05. If it is similar, if it is in fact smaller than 0.05, then we can conclude that there is a statistically significant difference between the mean scores of the two groups, and the null hypothesis can be rejected. Otherwise, the null hypothesis will be confirmed, and thus we infer that there is not a significant difference between the mean scores. We can also see the numerical difference between the means in this table. If you pay attention to mean differences column, 1.66. This is the numerical difference between the mean scores of the two groups. The confidence interval also tells us that in the population, the mean would lie somewhere between the lower and the upper levels, that is between 0.63 and 2.70 in this example. The second type of t-test is called paired samples t-test. If you remember, we said that paired samples t-test is used when you have performed an experiment and you have two mean scores, but the groups are not independent of each other. That is, you are comparing the scores of the students in the same group. This may be because you measured the same group at two different time periods, and you want to see if they perform better or worse at the second time period. Here are the attributes of paired samples t-test. Just like independent samples t-test, it has exactly two variables. One variable is categorical with only two levels, and it is the independent variable. People in each group must be the same. In the independent sample t-test, people in each group were independent, but here they are the same. And the other variable is continuous, and it is the dependent variable. The non-parametric alternative of paired samples t-test is Wilcoxon signed ranks test. In this figure, you can see a general schematic of the situation in which you use paired samples t-test. We have two times, time 1 and time 2. We have the same participants, they are in the same group, A, B, C, D, E, and A, B, C, D, E. So we have same participants. We have same dependent variable, and we have the same condition. The only difference is that these students or participants are measured at 2 time intervals. So this Pert samples t-test can look for changes between means when the participants are measured on the same dependent variable but at 2 time points. A common use of this is in a pre-test, post-test study design. In this type of experiment, we measure participants at the beginning and at the end of some kind of intervention. Here is an example. You have conducted a study on the effectiveness of a particular way of teaching reading. You have given a pre-test and a post-test. Each individual has 2 scores, a pre-test and a post-test. You want to know if the improvement following the treatment was significant or not. So here you have one group and you want to see the effect of, for example, a method of teaching reading. You, prior to this instruction of reading, you administer a pretest. Then you start, for example, teaching for 5 sessions. And then you administer a post-test. Here, each student in your class has 2 scores, pre-test and post-test. Now, you want to see if there is any improvement or not. Here, the statistical test that you need is a Pert samples t-test. Each person is paired with himself or herself on the 2 tests. This is another example. Research question. Would Persian-speaking students studying English benefit from an intensive and implicit grammar training in their second language? This is the research question. Now, the students were tested before the training and then after the training. Therefore, it examines whether the scores of the same group at different time periods can be said to differ, meaning that the group improved over time. So, if you look at the research question again, would Persian-speaking students studying English benefit from this explicit grammar training? We have a pre-test, then we have explicit teaching of grammar, and afterwards the post-test. So if students improve, the students' scores improve from pre-test to post-test, and we run a per sample t-test on the means of these 2 sets of scores, pre-test and post-test, this shows that students improved significantly, which means that this intensive and explicit grammar training was fruitful. This is an example of a Pert samples t-test table. The results of the Pert samples t-test here shows that there is a statistically significant difference between the mean of the reading pretest and the mean of the reading post-test. Again, if you remember in independent samples t-test table, I said that the most important column in this table is sig two-tailed column. The first thing you need to do is to find this column and look at the value. Here the value equals 0. 0 is smaller than 0.05. Therefore, it shows that the difference is significant. We can conclude that, for example, here it is reading pre-test and reading post-test. We can conclude that students improved significantly from pre-test to the post-test, and it shows that the treatment was effective. So today we talked about selection of statistical tests. We said that in the selection of a statistical test, we need to understand the distinction between tests of relationships and tests of group differences. Today we talked about tests of group differences, and we explained one of the most important types of these tests, which is called t-test. We in fact devoted this session to two types of t-tests: independent samples t-test and Pert samples t-test. This is the end of session 12. Good luck, everybody.